Hello! How is everyone doing today? Thank you. We got a very special episode of Coby's Brain for you today. We have Viraj Mehta on the show, aka Western Pup, and he is here today to talk about artificial intelligence, which is a topic that here at Coby's Brain we love to explore. So thanks so much for being on the show, Viraj. Viraj grew up in Austin, Texas, studied math and computer science at Stanford, and placed third in College Jeopardy! Give it up for that. That's incredible. He is now pursuing a PhD in robotics at Carnegie Mellon University. Viraj, it is great to have you on the show today. How you doing today, Viraj?
Thanks, Coby. It's great to be here.
Okay, so Western Pup, tell us a little bit about this PhD you're pursuing and how it pertains to artificial intelligence.
Yeah, so I'm doing my PhD in robotics. I never touch any robots. We have a general view of like what does it mean to be a robot, and that's any physical system that is controlled by computers that interacts with the world. And so, as you might imagine, that includes a lot of things that you think of when you think of artificial intelligence. That's self-driving cars, that's robotics, like when you think Roombas, Terminator, all the way up.
We love Roombas.
We love Roombas.
Give it up for Roombas. Sorry to interrupt you with that aside. Continue, please, sir.
Yes, we love Roombas, though. I'm in on Roombas as well. And so the idea is we take techniques that people talk about, like machine learning, like optimization, and like statistics. We apply them to solve problems that are kind of what I described. And so, in my case, I'm working on a really specific physical system that's basically a special kind of nuclear reactor that generates energy differently. But again, we're just looking at it as a control system that has some things we can change, some knobs we can turn, and like a lot of information about how it behaves under different situations. And we want to find the best possible way to wiggle those knobs and get the result we want. And so that is the same problem as if you want the self-driving car, you have to describe it that way. You have to wiggle the knobs appropriately. In that case, it's the steering wheel and the brakes and the gas, and you can get out an intelligent system. And so you might imagine this getting more and more intelligent, because in the end, you can write down a lot of the things we do as those same kinds of problems, which is, I think, colloquially the way you might talk about artificial intelligence.
So, Western Pup, why do you think it's important to start building awareness about AI at this specific point in human history?
Yeah. So first, I think it's important to, if you zoom out and talk about where has humanity come from? We were monkeys. We hunted. We gathered. We farmed. We've kind of been building structure up in civilization, really, from the beginning of like the story of life. And so, at some point along the way, some of the monkeys started doing math. That was, building block number one. Later on, we got computers. Math.
Give it up for math. You're important for all this stuff, right, math? Right?
Very cool. It's very important because in the end, all of the reasons why we do the computations we do with the computers is because somebody has proven that there are good properties about the systems we're trying to optimize or what have you. And so, enough of that was worked out kind of right around the last 30, 40 years for us to really like take a crack at these problems. So math, then another building block is computers. Started in the 50s. We've gotten to the point where we have like a lot of computers now that do a lot of computation, and way more than we've ever had. And then we've been also recording a lot more information about everything we're doing, even stuff like Wikipedia or like Twitter or like things that aren't like big data. It's just stuff that people put on the internet is all really helpful for understanding how language works and how images work.
So the data's key.
Yeah. So it's math, computation, and it's data. And then those three things basically got us to the point where we could get computers to start to do things, start to accomplish tasks, classify images, read text, generate text without us specifically like hardwiring how you would do that. And because it would be really difficult to specifically say, how do I decide what to say at all times? It's not something you can do. So it's where we're at right now, and that's really exciting.
Yeah, very interesting. That point you just brought up. So going off that, can you tell me a little bit more about how you can kind of, as you put it, get a computer to like do something without any like specific instructions about how to do that?
Yeah. So that is sort of what we work on every day, and it's that's like basically our job is to figure this stuff out, and it's a really exciting thing to do. Basically, I think the typical setup that most people might have heard about is you have a bunch of data where you have like, this is a picture of a cat, this is a picture of a dog, this is a picture of a tree. You have all the images, you have the associated labels, and then you have like some big machine learning model that does the actual like learning and prediction over these. And so a little bit about how that works is that you have basically like a model that has a bunch of numbers in it that you can change, and that'll change what the model ends up predicting. It's big and it's complicated, and it can approximate lots of things. So in order to pick the thing to approximate, which is ideally a dog classifier like me, you might want to, you basically start with something random, and you look at where you are, you do a little bit of calculus, and then you take a little tiny step in the direction that you think will like make it a little bit better, and that's from the calculus. And then you do that a lot of times with a lot of examples, and you sort of practice and you screw up, and then you get off in the wrong direction, you get on the right direction. But on average, you end up going in the right direction, and eventually you get good at that. That is your dog classifier, except it's happening with numbers. I feel like it's pretty similar, honestly, to how I live my life, which is to generally screw up and then end up going in the right direction. So I find that interesting. And then we get to do math about that, basically. And so that's like the simple classified, supervised learning setup. What I think is more exciting and is closer to what I work on is basically, instead of having labels, you have some environment that you're working in that has basically, you can step through it and make decisions about what you're doing. And in the end, you get some reward. And so you can describe what you want the AI to do by just kind of deciding that, I want you to get the plane to the other runway and land it. And you don't specify what to do with the controllers, what to do with the yoke, what to do with the throttle. It sort of tries things and fails, and then tries things and fails, and eventually will take off, land, cruise, whatever on the way. At least in theory. I don't know if it would work for something like flying a plane. But the idea there is that there are whole behaviors and whole strategies that evolve without you telling it what to do, which is, I also think, super exciting.
Very interesting. That's like pretty crazy, actually. So basically, you're saying the AI is kind of like learning or figuring out how to do things without us even telling it how to get those things done. That's awesome, yet somewhat terrifying. The question actually that brings up for me is like, are you worried that it'll start doing things that we don't want it to do? Assuming that it's capable of, figuring out how to do things on its own that we're not even telling it to do. Like, what if those things are things we don't want it to do?
So in a word, no, I'm not too worried about this. I think that it's a really interesting area to study, and we should study it though, because I might be wrong, and that would be a big deal. So let me explain a little bit about sort of what the general thinking is in this space, and then we can kind of go into, what the consequences of that might be. And so so right now, if you think about the progress of AI, you have each of these like little pieces of math and all of these little ideas about how to do computing faster and ways to use data, all sort of progressing. And there's like 3 conferences a year, and people come up with ideas, and you do that. You go to the one in March, you go to the one in August, you go to the one in December, and then and then the AI slowly gets better as people learn about these things and keep trying. And it happens at a human time frame. So it happens on the order of years, like we work on things. But let's say, like as a thought experiment, you had some system that you had its goal was to make a slightly better version of itself, whose goal was to also make a slightly better version of itself as measured on maybe an IQ test or the Turing test or some goal. And that system was, maybe worse than a human at first, but was able to operate on, silicon timescales, which are, you'll do billions of operations in a second, things move faster, nobody sleeps, and you'll end up doing things at a much quicker rate. So instead of 3 conferences worth of advancement in a year, you're going to get maybe 3 conferences worth of advancement in a second if you have enough computers. So the idea would be that runs much, much faster. And so in 3 weeks, we have, dozens and hundreds of years of AI progress happening on this one thing. And it's like much, much smarter than us. It's much, much more capable of doing things. It sees us the way we see ants. And at that point, you start to run into a lot of questions about what will happen when something smarter than us exists, like a lot. How do we make sure that humans have autonomy? How do we make sure there's like a classic example of like, Coby, do you have a paperclip?
Do I have a paperclip? Yes, I do have a paperclip.
Okay, I'll buy it off you for $1.
Okay, got it.
Now you own a paperclip company.
Oh, correct, because I sold you a paperclip.
Exactly. So, Coby, you own a paperclip company. Let's say you had a paperclip
businessman.
AI that was
Coby's brain, a businessman.
Coby's brain, a tycoon.
A paperclip tycoon. Sorry, continue.
Exactly. Right. So, as a paperclip tycoon, you would want you have an AI because you have a lot of friends, and you get an AI that is, you tell it to make as many paperclips as you can. It's going to be the paperclip AI, and so it gets about to doing that, and like an evil genie or something, it's like, all right, I'm going to make as many paperclips as I can. So there's some iron in the crust, but there's also some iron in the mantle of the earth. There's also some iron in the core of the earth. So let's start. We're going to have to get all of it. Let's get all of it. Also, there's some iron in the blood of every human being. There's some iron in the moon. We'll get it all. It's all good. It's ours. We're going to make it into paperclips. We're going to make as many paperclips as we can. There's even some iron in Coby's brain and Coby's microphone.
We don't like that.
Yeah. So we're going to have to be careful about what level of, what kind of questions we ask this AI. If it's a paperclip AI, we're gonna have to do a lot better than make as many paperclips as we can. But in general, like, we want to make sure that in general what the AIs do are in the best interests of humanity, and that people remain like autonomous, happy creatures as long as this continues, as this continues to progress. And if we ever get that far, like, then you start to run into these kinds of questions. And so that's, I think, the argument for being at least concerned about this. Yeah.
I mean, I feel like that's kind of scary, though. It's a kind of a potentially scary situation. Like, if the AI has some, like, kind of, like, it doesn't care as much about human brains being intact as they do about producing paperclips. So, yeah, please don't hurt me, AI. We love you. We trust you. Give it up for AI. We are big supporters of you, AI, here on Coby's Brain. Western Pup, like, given this, like, these points that you kind of bring up, it seems super theoretically possible that, like, an AI overlord situation will probably happen. Like, do you think that's gonna happen?
So, I mean, in a short answer, probably. In a short answer, probably not. But it's a bad enough outcome that we should care about it. I think you can kind of break that question into 2 pieces. One is, like, are we going to technically be capable of making something that smart? And 2 is, can we get it to be a positive force for society? Because in the world where we have AI that's, like, extremely powerful, but also, like, good for humanity, it's really good. I don't think anybody has to work anymore. I don't think anybody, like, we run out of much stuff. Like, I think humanity is much better off. But even that has dangers, which I'll get to in a minute. But the other question is, like, so if first it's possible, if it's possible, the question of whether it's possible is, like, I think, wide open. There have been a lot of, this has still been a fast moving field, even though I talked about how slow it is relative to computers in the past. And we've seen a lot of progress in the last 10 years. And I would imagine that since our brains are possible and you, Coby's brain, are possible.
Thank you. Thank you.
That this is a backhanded compliment because that simulating you in software would also theoretically be possible. And so I would imagine that simulating maybe even a better version of you in software would also be possible. And so this has to be possible. On the other hand, like I think the question about AI as a like whether it will work for our benefit or to our expense is really linked to questions about philosophy, because you have to specify in really extreme detail what you want in order for a computer to understand it.
I was going to say, like it seems like we need to understand what the interests of humanity that we want advanced by AI we need to understand what those even are.
Yeah, and that might be questions around wealth allocation. That might be questions around autonomy, questions around like what is crime and then punishment. Like these are all the really deep questions about organizing humanity that we've been dealing with forever. And, we have theories that are more or less precise about how to maximize collective utility or how to live in a way that doesn't treat humans as means to an end, or how to live virtuously. Like there's a lot of these ideas that you and I, Coby's brain, picked up in neuroethics classes back in school.
True.
But
give it up for the neuroethics class. Great class.
Yeah. And so what a lot of these people do who work on this topic is take a lot of the ideas we learned in neuroethics and in general from philosophy and try and formalize them in terms of math and computers and see whether you can satisfy a lot of these definitions, or you can direct the AI to work well with humans. And we even do small experiments with like human robot communication and interaction and collaboration in my school, which is really cool. I think the other issue.
I think I feel like this is bringing up a lot of really, really kind of crazy points. Like, right, like who is. Like, right, again, we don't know what is perfectly ethical and what isn't. And so it's basic that the system of ethics that these AIs are going to have to work with is just kind of based on whoever programmed it, right? So how do we know that the right people are going to be the ones programming these AIs?
Well, that's a really good question. So you see, like, kind of in the global community, people work on this. Like, a lot of universities are the leaders in this field. Stanford, Carnegie Mellon, MIT, Berkeley, especially. And then you see corporations like Google and Facebook. And then you see, foreign countries. You see a lot of researchers in China and the UK and Europe and other places going through and publishing the same paper. So it's, on the one hand, a really open and global field. On the other hand, there's a lot of money in some of these places. So Google, Facebook. There's a startup specifically called OpenAI that was looking at trying to be this very like thoughtful, democratic leader in AI research. And so far they've released some really interesting things and also kept some really interesting things secret. And there have been some changes to their governance model. So it's really unclear. And one of the fascinating things about working in this field is who will ultimately control the technology. And we work hard to make it as open and democratic as possible.
Yeah, I think that's really good. The other question that brings up is, AI is capable of accomplishing things that we as humans haven't been able to. Do you think that AI will be able to crack the code of like what is at the theoretically impossible philosophical question of what is like correct ethics? Could AI figure that out and then implement that?
There are a lot of weird consequences in when you start to really push some of the philosophical definitions of utility or ethics all the way to the end. Like, for example, if you are a utilitarian and you think that an AI as its goal should maximize the happiness and well-being of humans and sentient creatures, you might try and ask the AI to maximize it. But, kind of by the same argument I used earlier, that we're probably going to be able to build AI because it should be in principle possible to simulate a brain. if the AI, at all gets wind of the idea that it is also a thing that is thinking and living and sentient, then you can kind of reason that a simulation of Coby's brain might have the same ethical value as Coby's brain. And then at that point, the Earth supports 7 billion people right now, 7 plus. Let's say the AI could be really effective at managing our resources and we can support 70 billion happy people. Even that is going to naturally be way less efficient than if we were to simulate people, because you could just make the whole Earth into a lot of computers and do it much, much faster and at much, much higher scale. And so you could have 70 trillion people simulated on the Earth if it's all computers. And so maybe that's the right utilitarian decision to make. I don't know that in and of itself is a convincing argument, but it hopefully beckons at the fact that there are a lot of possibilities.
We could
about how to interpret these things.
We could simulate all possible outcomes, and the AI could be like, all right, let's take humanity on the best path, is kind of what you're saying.
Well, that's actually another good idea. But what I was saying was that instead of real people, we can just simulate more minds having a good time, and that'll accomplish the same goal as having real people running around doing stuff. They will still have, if you believe in this sort of thing, they'll still have the same ethical value and autonomy that the human in the real world would.
I see. But thinking about this, the fact that these AIs are going to be able to, and powerful GPUs are going to be capable of running these simulations, begs the question for me, Viraj, what's your take on the possibility that we're kind of just living in one of those simulations now?
Coby's brain, my question to you is does it really matter? In the sense that you kind of are familiar with your experience as a brain bouncing around sometimes in the back of Coby's head and sometimes on stage, but in the end, does it really change anything if this is running on some other hardware somewhere?
I mean, in theory, it would be good. I think why is cosmology or questions of where humanity came from? Why is that or purpose? Why is that why is that existentially interesting? I feel like such a question could have a lot of implications about maybe how we should go about living our lives, knowing what life even is.
I think I might actually disagree with you on that point, Coby. To me, life is worth living because it's the only one you've got.
The audience seems to like that. Continue.
Yeah, life is worth living because you only have one life. You got to do the best you can with it. You think, therefore you are, like Descartes would say, and that should be enough justification to do it. That being said, I think those questions about where we came from, where the universe came from, where does it maybe end, what happens, why does it all work the way it does, are interesting for reasons of unlocking other cool technologies, satisfying curiosity. But I don't think that I need it as motivation on why to live a meaningful life.
Yeah. Super interesting debate there that honestly could probably go on for a while. Do questions of cosmology even matter? You heard.
I do.
Sorry?
I do have an interesting angle on, because I didn't answer your question, Coby.
Oh yeah. Answer the question then.
I want to answer your question because there's also an interest. It's fun to. So the way you would think about the actual odds that we're living in a simulation right now, it basically depends on what is the probability, independent of us being in it, that we would be able. Society would evolve to the point that it was able to run computers at scale and do these kinds of simulations. And then how much does one of those simulations cost? And then, so how many of those would there be? And then can you do, if you're in a simulation, can you do another simulation? So the idea would be you would try and count probabilistically the expected number of total realities, and then you would then say that your probability of being in like the real reality would be 1 over that number. And once you have that probability of that you're living in a simulation, you would, I just don't know what that information would like buy. That's why I'm like, that's how you would maybe come up with those odds. But I think kind of from Descartes, I would imagine that it doesn't matter.
Yeah, I mean, it's super interesting debate. We could have a whole nother episode about that. Maybe we should. What do you think, audience? Okay. Then coming soon, simulation theory. Does it matter? With Western Pup. Coming soon to Coby's brain. All right, Western Pup. We got one more question for you. We've been having a great time here on Coby's brain. And we got one more AI-related question for you. So here on Coby's brain, we seek to eventually compile all the data that Coby's brain communicates digitally into an AI that could eventually, post Coby, mimic his personality and potentially, immortalize all of us, given whatever data that we possess, like our Facebook profiles, Instagrams. So with that data, do you think like a personalized, immortalized AI is possible? And 2, what would the implications of that even be?
So I actually think this is, I have like a very technical answer to this question. And I think it would actually be fun to talk through it if I can do that well.
Please.
And then I want to start with the implications. Actually, no, I'm going to end with the implications. So, like I said a couple times earlier on the show, it should be possible, in principle, to have a big model that looks like Coby's brain. It would have at least the same shape as Coby's brain, let's say, but then kind of the way your brain works, at least at a really, really general level, is that, the neurons talk to one another, and that the relative power, the relative amount that they talk to one another and how like seriously they take one another is what actually does the thinking. And so you should in principle be able to like have that model exist on a computer or a big computer, but then to actually find the exact model that is the same as Coby's brain without measuring every inch of every nanometer of Coby's brain and killing Coby's brain, which is bad, would be to
bad.
Would be to
don't do
look
it.
At all the data that don't do it. We're out on that. But looking at all the data that Coby's brain has put out in the world, and then starting to like find the minimum error brain, like we talked about earlier. And so there's actually a whole branch of math about how much data Coby's brain would need to put out in order to be guaranteed that you would get something very close to Coby's brain in simulation. So that's there's a whole lot of math about that. So I can give you a very precise answer after the show. But for now, it's like really an interesting question. I think the implications could be really interesting. First off, if it's close enough, if it's essentially you would maybe live forever. You could live forever, depending on how you look at it. And so you said immortalized. I don't know how seriously you meant that word, but that's kind of what I mean. And that's kind of what the simulation thing is all about. But there are also implications about, can we make sure that simulation Coby's brain is treated well? Can we make sure that people will consent to that kind of thing? Can we make sure that, it's done in a fair way that benefits people equally? Can we, there are these big questions about that kind of ethical existence. And so I think it's really interesting to ponder these questions. And then also, I'm very grateful that I learned from awesome people, work with awesome people, and get to like sometimes tangentially touch them.
Yeah, it's kind of like we can continue to learn from these people after they're gone. Well, thank you so much for being on the show today, Western Pup. It was a real pleasure to have you on the show. Everyone, give it up for Western Pup.
Thanks for having me, Coby.
This was a time. This was one for the books. Thank you so much for watching, everyone, and see you next time.